Welcome to lesson number 5 in the atomic theory unit. We're going to deal with the weighted average. Having talked about isotopes, we're now in a position to discuss something called the weighted average. The first thing I want to point out is, well, where have we been? We've talked about something called the mass number. And of course, that's the sum of the number of protons and neutrons in a given nucleus, in a given isotope. We are now going to talk about something called the atomic mass. Guys, one thing I have to stress to you is that the mass number and the atomic mass are not synonymous. The atomic mass, as we're going to see, is an average, a weighted average of all of the naturally occurring isotopes of a given element, whereas the mass number only concerns one specific isotope of an element. Let me write that as a definition for you. Rather, let me give you the definition of atomic mass. The atomic mass is a weighted average of the mass numbers of the naturally occurring isotopes of an element according to their percent abundances. So what does that mean? Well, let's look at that in terms of, well, the formula. The formula is not given to you on your reference table. It's something you have to memorize. So let me write it out, and then we'll discuss it. So the atomic mass, this weighted average of naturally occurring isotopes, is equal to the mass of isotope number 1, the mass number, I should say, times its percent abundance, plus the mass number of isotope number 2 times its abundance. And you would keep doing that for every single naturally occurring isotope there is. Some elements could have 5, 6, 7 of them. Practically, you'll see ones with 2 or 3, occasionally 4, although that gets really annoying for when we do an example. I can show you why that is something students wouldn't want to go through, understandably. But again, what does it mean to calculate the weighted average of something? Probably the easiest thing for you to relate to is your grades and how one weights different assignments, different assessments, and how those assessments are averaged together according to a weighted average. Let's take a look at an example of that. We'll say you're in a science class, and in that science class, in one marking period, you have 1 lab, 1 quiz, 1 exam. We see that on the exam, you didn't do terribly well, 70%. The quiz, you did extremely well. And on the lab, you got, likewise, a perfect grade. You worked very hard, and you are reaping the benefits of your hard work. Now, we wouldn't be surprised if you're, based upon our common sense, we know that this exam is weighted much more heavily than your other 2 assessments. In fact, in our class, half of your grade, 50% of your grade, comes from that one exam. 30% of your grade comes from that quiz, and the remaining 20% comes from that lab. So we can use that weighted average formula very easily to figure out what your grade is. Let's see. Let's plug the numbers in. First of all, let's adapt the formula slightly. Instead of mass numbers, we're going to put in grade numbers here. So I have the lab, grade number 1, the quiz, grade number 2, and the exam, grade number 3, times its percent weighting. Let's plug the numbers in now. So your lab has a score of 100. That's weighted 20% of your grade, plus the quiz grade of 100 times its weighting. It's 30% of your total marking period grade. Your exam on which you got a 70, that 70 is weighted. It's 50% of your grade. And when we do the math, we find the following. In the numerator, 8,500 divided by 100%, yeah, so you're going to wind up with an 85%, because obviously the 70 pulled that grade further down towards it, given its relatively high weighting. Now let's use the formula as intended to actually determine the weighted average, the atomic mass, the weighted average of the naturally occurring isotopes of carbon. So there are two naturally occurring isotopes of the element carbon, carbon-12 and carbon-13. Their masses and relative abundances are given below. They often place things in this table, which, as I'll point out, is a way actually of reminding yourself what the formula is, given the fact that it's not listed on table T. If you notice, I did write down the formula. It's probably the nicest question you can get because there are only two isotopes, so only two terms. It's very straightforward. It says that the mass of the first isotope is 12. Let me put that in here. So I have 12 times the percent abundance, 99%. The second isotope has a mass of 13 point, I'll just write 13, times this percent, a low 1%. I'm going to divide that by 100. When I get that, it's a 1188 plus 13, which gives me 1201. Of course, that's divided by 100. So I get an answer of 12.01. And that's not going to surprise us at all, because if you just take a trip over to your local periodic table and you look up carbon, it's going to list a mass of 12.011. 12.011 because it was based upon more accurate information, but it's making the point that the atomic mass is in decimal form because it's a weighted average of the naturally occurring isotopes. Let's go backwards in order of these questions. It asks in number 2, why is the weighted average so much closer to 12 than 13? Well, think of it this way. One of them is 12, one of them is 13. A straight average would give an answer of 12.5, but that would mean the weighted average would be 50% 12 and 50% 13. Since the average is so very close to 12, 12.01, it shouldn't surprise us because 99% of the carbon-12 of the carbon has a mass of 12, whereas only the remaining 1% is 13, so that 13 pulls up the average ever so slightly away from 12 to 12.01. Finally, this goes back to the previous lesson, explain in terms of subatomic particles why these are different isotopes of the same element, because it doesn't matter what isotopes are talking about. It's always the same explanation. The difference is different numbers of neutrons. And the similarity is the same number of protons. If you write anything other than that, we can't give you credit, even though you are stating the truth. Well, very well. That is the end of our 5th lesson on the weighted average. I'll see you in lesson number 6 in this unit of the atomic theory.